Hi all, in this video we will focus on kinetic and equilibrium. In this video our topic is reversible reactions and dynamic equilibrium. Chemical reactions are usually reversible, meaning that they can proceed in both directions. We write a reversible reaction with a split arrow to indicate this reversibility. The equation indicates that A can form B and B can form A. Equilibrium means that the opposite rates are equal. At equilibrium, the concentrations of the reactants and products need not to be equal. To see how equilibrium can be achieved in this system by referring to the accompanying diagrams of reaction rate and concentration as function of time. If we refer to the graph below, we note that as time goes on, the rate of forward reaction A to B decreases because the concentration of A is decreasing. Meanwhile, the concentration of B is increasing and the rate of reaction B to A is also increasing. After a time, the rates of both forward and backward reactions will be equal. At this point, the concentrations of the reactants and the products will no longer change. We call this condition dynamic equilibrium and we usually indicate it by using split arrows. Concentration graph at equilibrium. We know that phase changes are reversible and in a closed container two or more phases may exist in dynamic equilibrium at a given temperature and pressure. Example, if water is placed in a closed container at 25 degrees Celsius, it will reach dynamic equilibrium with its vapor. The pressure created by the gaseous water at equilibrium is the vapor pressure of water at 25 degrees Celsius. Similarly, boiling, condensation, melting, freezing, and sublimation, deposition all represent phase equilibria. When a solution dissolves in a liquid and produces a saturated solution, the rate of dissolving equals the rate at which the solid leaves the solution, means crystallization. This situation represents dynamic equilibrium in the solution. Solution equilibria are affected by changes in temperature. Gases dissolved in liquids. In a closed system such as a bottle of soda, equilibrium may exist between the dissolved gas and the gas present on top of the liquid. Gas equilibria are affected by changes in temperature and pressure. In our next video, we will cover the topic of chemical equilibrium and Le Chatelier's principle. So don't forget to like and subscribe.